In this video, we want to solve this 2020 JEE advanced integral questions, right? So we are given the little f to be a real value function over the real domain, and it is a differentiable function such that its derivative is continuous. Then we are given this big F to be a real value function defined over this closed interval from 0 to pi, and the big F is defined as the integral from 0 to x of the little f of t dt. That means if we integrate f of x, we're going to have the big f of x. That's just what we mean. And if this integral here is equal to 2, then we have to find little f of 0. Okay, that's exactly what we're going to do. We want to find little f of 0. And we are going to start off with this integral equation we are given here. So we are given the integral from 0 to pi, right? And you should notice that I can split this integral at the same time, given that the integral of the sum is the sum of the integrals. That means we are going to have f prime of x times the cosine of x dx, right? And then we're going to add it with 0 to pi of the big f of x times the cosine of x dx. And then we equate that to 2. Okay, so you split this to everybody inside, and then you split the integral. Okay, so after doing that, now I want you to notice something really interesting here. If we have the integral of, let's say, e to the power of x times the cosine of x dx, right? This indefinite integral, without definite, but let's just put indefinite here. We don't want to worry about the definition of the function on that interval. We use integration by parts, isn't it? And we apply that 2 times. The derivative, maybe if we want to integrate this, and maybe we want to differentiate this, and in the end, we will not simplify everything, but we will get back to the original question, the same form, and we usually make something subject of formula, and then the other part will give us what we want. And that's exactly what we are going to be doing here. Given that, if we integrate this, we're going to have little f of x. This is the little f prime. So integrating it, we're going to have little f. Integrating it again, based on this definition, we're going to have big F of x. Differentiate this once, we're going to have negative sign. Differentiate it again, we're going to have negative cosine. So in fact, that is really interesting, isn't it? So we are going to do the integration by part, and I'm going to set it up using the DI method. Okay, so you can check it out from black pen, red pen, DI. This is a differential operator, and then this one is the integral. So it will help us to differentiate. This will help us to integrate. All right, great. So we're going to do the next thing we'll do is to alternate the signs, plus, minus, plus, and so on and so forth. But we are going to stop here because we just want to apply the integration by part twice. All right. Okay, so doing that, let's see what we have. Well, this is the derivative for differentiate. Let's choose cosine to differentiate in this case, right? So we put cosine of x here. And then when we differentiate that, we're going to have negative sine of x. We differentiate this again, we're going to have negative cosine of x, right? Just by differentiating. And then we integrate this right here. What are we going to integrate? Of course, it must be f prime of x, isn't it? Okay, so we integrate f prime of x. We do that, we're going to have little f of x when we integrate it just once, because this is a derivative. And then when we integrate it again from that definition, we're going to have big F of x. If we are to use this other part, all right, we are going to differentiate this big F of x and then integrate the cosine. It's going to work out the same way, all right? Now, when we're done with that, the next thing is to multiply the diagonals out, multiply this with that, multiply this with that, and then we are going to integrate the product of this last row, all right? According to black pen, red pen. So you check out his videos on this. Integrate the product of this last row. So we're going to multiply this with that, all right? That is from here. So that means we are going to have, so this tells us the integral of this one will give us this. So we're going to have big little f of x, all right, times the cosine of x, and we have to take that from 0 to pi, remember? And then we're going to take the product of this second diagonal, this times that, that will give us positive sine of x, all right, times big F of x. So you take that big F of x, and then we have to take that from 0 to pi, and then we integrate the product of this last row. So we multiply this with that, we're going to have positive times negative, that will be negative cosine of x, all right, times big F of x. Okay, but remember, we have to integrate that from 0 to pi, and then we put the dx over here. That is for the integral of this. We will just maintain this one as it is, that is 0 to pi of big F of x, all right, times the cosine of x. We'll just maintain that dx, and then we equate that to 2. Okay, that's nice, isn't it? So let's see what we have. Well, you notice that this and that are exactly the same, all right, except for their signs. Their signs are opposite, so that means their sum will give us 0. And when that happens, that tells us that the sum of these two will give us just 2, right? So that tells us that when we evaluate these two, we're going to have 2. Well, as we usually do, we are going to substitute the bounds of integration as well. Take note, this is a little f, right? So we're going to have little f of x. When x is pi, little f of pi, alright? And then we are going to multiply that by cosine of pi, which is, of course, -1. So maybe let me just put a -1 here. And then we add it with, well, okay, we are not yet done. We need to substitute 0, isn't it? So we subtract, well, little f of 0, and then we are going to multiply it by cosine of 0, which is just 1. Okay, we are done with that part. Then we substitute pi into each of these. We will substitute pi for the sign. We're going to have 0. Alright, that means the whole of this will be 0. We substitute 0 for x. Sine of 0 will just be 0. So everything there is just 0, and then we equate that to 2. Okay, that's nice, isn't it? So you notice that little f of pi, well, in the given question, we are given little f of pi to be -6. Alright? So since little f of pi is -6 and this is already -1, that means everything here will just give us 6. Minus little f of 0. Of course, that's what we asked to find. So we are going to try to make this the subject of formula. Alright? Little f of 0. Let's just put it down as it is. Little f of 0. Alright? When we add 0 to that, this is equal to 2. Of course, that already tells us what the little f of 0 is, which is just 4. Subtract a thing from 6 and you get 2. That thing must be 4. So that tells us that little f of 0 is in fact equal to 4. And that's exactly what we asked to find. Let's put it well. Okay, that's nice, isn't it? Alright, that was easy. Okay, thanks for watching, and please subscribe to my channel, share this video with your friends, and I'll see you in our next video.